Bismillahirrahmanirrahim and Assalamu alaikum. This is Faryal Javed, roll number 21TE07 from Telecommunication Engineering Department, UT Texila. So today we are going to solve lab manual 4 of digital signal processing, that is analyzing discrete time linear time invariants. So the lab objective of this lab is to analyze discrete time linear time invariant systems. As we all know that LTI system basically plays an important role in digital signal processing due to its several key factors, and the most of all is its mathematical simplicity. That is, it's basically easy to solve a differential or difference equation as compared to the non-linear systems. So, moving toward task A of today's lab, that is, how would you differentiate between signal and system, explain the key characteristic of each, and provide example to illustrate their role in the context of signal processing. So, here I've uploaded a picture showing a difference of signal and system. A signal is basically any time dependent physical quantity. On the other hand, a system is an object in which input signal interact to produce an output signal. And another definition to signal is a physical quantity that varies with respect to time or space. An example to it can be an audio recording of a person speaking, representing the information carried in their voice. On the other hand, a system is basically a digital filter processing. A noisy audio signal is used to produce a cleaner version by removing a background signal. Moving toward task B, that is, how does a linear time invariant system play a crucial role in digital signal processing? Considering their mathematical simplicity, adherence to superposition principle, and efficiency in frequency response analysis. So, here is the mathematical form of LTI system as shown in the picture. So, LTI system basically adhere to the superposition principle, which states that the response of system to a sum of multiple input signal is equal to the sum of individual responses to each input signal. As shown here in is the causal system in which a two input signal can be converted into a single output. So the superposition principle basically allows us for modular design and analysis of LTI system, where subsystem can be analyzed independently and then combined to analyze the overall system behavior. And the efficiency in frequency response analysis can be a linear relationship between input and output, characterized by their frequency responses. So it can be analyzed efficiently using techniques such as Fourier transform. So moving toward task C, that is, what are common method for signal decomposition, specifically focusing on their technique like impulse decomposition, step function analysis, even odd decomposition, and Fourier analysis. Explore how these methods contribute to breaking down signal and their applications. So here are the graphs showing even and odd signal, and then we'll have step function, and then a graph of Fourier analysis. So basically, an impulse decomposition represent a signal as a sum of scaled and time shifted impulses, and that basically used for the analysis of spikes. On the other hand, this step function is also used for the same purpose. However, it uses a signal that is a piecewise constant, such as a square wave. On the other hand, this even odd function provide an insight into asymmetry or asymmetry properties. And then we'll have the Fourier analysis that decomposes a signal into a sinusoidal components, as you can see here in the graph. It's basically essential for analyzing a frequency contents. Moving towards task D, that is, what is convolution or how does it play a significant role in digital signal processing? Explore the fundamental concept of convolution and elaborate on its importance in various DSP applications, such as filtering, signal processing, and system analysis. So here is a graph of convolution, and then the examples, that is cross correlation and autocorrelation. Convolution in DSP basically combines two signal and then produces a third one, and capturing the essence of linear time invariant system. So it basically modifies signal by convolving them with filters, and in system analysis predicting output for any input by convolving with the system impulsive response. As shown that here is the applications, like it is used in the task of signal processing. Here is the graph showing autocorrelation and cross correlations. Then the task E, that is, when do we correlate two signals and what are the key applications or scenario when where signal correlation is crucial in various fields such as communication system, radar, sonar, image processing, biomedical signal processing, control system, wireless communication, and seismic signal processing. As we've discussed above, that it has various applications in signal processing and correlation, that is autocorrelation and cross correlation. On the other hand, it has a cornerstone in DSP for operation ranging from reduction to a pattern recognition. And then we'll have the task one of the MATLAB, that is make your own customized function that take two input from user and show convolution sum graphically. So here is the task one, that take two inputs from user, and here we'll take the first signal as 1 2 3 4, the simplest one, and then the signal 2 as 5 6 7 and 4. Then the output to this signal is as shown in the graph. It basically uses the time vectors, that is n of x and n of h, and created the output as n of y. So here it takes the input signal x of n, h of n, and then we'll have the convolution sum as y of n. The resulting plot basically provide a visual representation of input signal and their convolution sum. This function aids in understanding the effect of convolution in signal, and it has previous applications. Moving towards task 2 of MATLAB, that is make your own customized function that take two input signal from user and use flip and slide method to show convolution sum step by step, and hence use pause command to stay and see stepwise convolution results. Here it take the two input from user. Let's give it 2 2 4 4. Then the other one 1 3 4 and 2. Oh, let's do it again. And here this task 4 basically shows the two input from the user, that is x and h. It compute the convolution of the input signal using conv function basically, and then the input signal x of n and h of n are plotted in separate subplots. The convolution sum y of n is plotted in another subplot. As you can see, the function adjusts the figure properties, including setting the figure and size, position, etc. The resulting plot provide a visual representation of input signal and their convolution sum. Moving towards task 3 of today's lab, that is compute the response of following system to an input, that is h of n and x of n, and build a user defined function. For this example, four arguments will be passed, that's input x of n, information about its origin, and the impulse response. So here our task 7 basically use a convolution animation, and this convolution animation MATLAB command window, it entered two input signal and each enclosed in square bracket, that is 1 2 3, and can be anything else. This function will then display the convolution sum step by step, and it flip and slide the method. Then we'll have task 4, that is we have the impulse response of system n. For x of n, find y of n if fed shifted version of input signal x of n, what kind of output will we receive? It's similar to the other one. However, this code will provide a comprehensive visualization of convolution operation, aiding in understanding the relationship between input signal and impulse response. So this is it for today's lab. Thank you so much. Allah Hafiz.